Homeostasis, remember, is a word that Walter Cannon coined. And what does the autonomic nervous system have to do with homeostasis? In general, there are two ways you can think of things sort of staying the same. One way is by a integrative physiology point of view. You've got a homeostat, like a thermostat, for instance. And it's comparing the information about what's going on with some set point for responding, and when there's a discrepancy, then the effector gets turned on and the regulated variable is controlled. There's a lot of teleology involved here. That means teleology basically is a school in philosophy based on the ends, the goals. What's the goal of a thermostat? The goal of a thermostat is to keep your temperature. Well, who says? And the inside the body, no one has ever found evidence for a comparator, including a thermostat, even though, of course, your temperature is very closely regulated. The alternative view is a systems biological point of view, which in essence says, you know why your temperature is held in constant? Because that's the way it is. That's the way it is. All the organisms that didn't do this died out in evolution. And don't give me this story about the purpose of a particular reflex or whatever. The reflex is there because it's there. So that's the systems biology point of view. But I'm going to be going with the much more easy to understand integrated physiological point of view. The reason that a monitored variable is held, the level is held in check, is because of negative feedback. There's a homeostat of some sort. So this is a classic picture of the way blood pressure is supposed to be regulated. There's a barostatic system. When the blood pressure goes up, there are these receptors that are stretched because of the increase in blood pressure. That causes a nerve traffic to go to some barostat in the brainstem. You remember the brainstem is that's the chewy chocolate center of the Tootsie Roll Pop. And then there's outflow, autonomic outflow. When the blood pressure goes up, the heart rate goes down. And when the blood pressure goes up, the sympathetic nervous system is turned off, and so the blood pressure tends to come back down. So that's a kind of a simple but often sufficient explanation of a barostatic system. Now, in humans, a substantial number of the baroreceptors, which are stress receptors, are in the wall of the carotid sinus. The wall of the carotid artery, where the carotid artery splits into the internal and external carotid. Right there is carotid sinus, and there are sort of hybrid cells that are sensitive to stretch, and when stimulated, when they're stretched, there's an increase in afferent traffic to the brain by the carotid sinus nerve. If you've ever watched professional wrestling, you may have come across the sleeper hold, where somebody quickly goes around to the opponent's back and sort of massages this part of the person's neck. Doesn't choke them, that would be a disqualification. But just sort of massages, and then the person falls asleep, just faints and collapses to the tarp, and that's the sleeper hold. When I was a kid, I remember there was a professional wrestler named Argentino Paulo, I think, who I think that was the guy who used the sleeper hold a lot. I'm not sure that professional wrestling is really like a competitive sport. I'm not sure. But I do like the idea of the sleeper hold because it tells you that when you mechanically distort the carotid sinus, the baroreceptors there kind of think that the blood pressure has gone up. And so it causes that reflex to occur where vagal outflow goes up, sympathetic outflow goes down, and the blood pressure goes down, and then the person loses consciousness. I think of the baroreflex or the barostat as kind of a metaphor. This is the way it actually looks in the brainstem and higher up in the central nervous system. There are all sorts of interactions between all sorts of centers, but conceptually, you have a barostat. A barostat doesn't exist. It's a metaphor, but I think it's very handy because this is tough to understand.